What if I told you that coding in Salesforce is a superpower waiting to be unlocked? Your knowledge of flows can be used to trigger your coding powers and can supercharge your evolution into a Salesforce developer. Speaking of triggers, record trigger flows are very similar to Apex triggers. Join me as I take a high-level look at the shared features across flows and Apex triggers. It's time to elevate your skill set. Data is constantly changing in Salesforce orgs. New records get created, existing records get updated, and non-essential records get deleted. Triggered automation is one of Salesforce's cool features that allows certain actions to be performed automatically whenever these data changes occur. Let's take a closer look at a blueprint of a simple Apex trigger. An Apex trigger consists of 5 main parts. There is a trigger declaration, trigger events, event checks, trigger context variables, and finally there are trigger handlers and business logic. I have prepared a few examples that are designed to help you grasp key concepts while gaining a high-level understanding of Apex triggers. However, when you start preparing triggers for clients, you should reference the Salesforce documentation to ensure you are following best practices. Now that we've addressed that, let's take a closer look at the different parts of an Apex trigger. When you create a new record-triggered flow, you have to specify the name of your flow and the Salesforce object that should trigger the flow. When creating an Apex trigger, the first thing you'll write is the trigger declaration. This declaration consists of the Apex trigger name, which should follow clean code best practices, and the name of the Salesforce object that the Apex trigger will run on. For example, this trigger is named product trigger and is ran on the product object. The next part of the trigger declaration contains the trigger events. When you create a record-triggered flow, you must select when the flow should run. You have the options of running the flow when the record is created, when the record is updated, or when the record is deleted. As mentioned in earlier videos, these are known as DML operations. Apex triggers also allow you to define the DML operations that will trigger your code to run. These events will be defined in the parentheses of your Apex trigger. You may also notice the before and after keywords shown here. Apex triggers can run before or after DML operations occur. Trigger events that occur before a DML operation are similar to the fast updates option in record-triggered flows. Before triggers come in handy for data validation and field modifications that should occur before a DML operation. For example, if we want to prevent products from being created, we can use a before insert trigger to handle this requirement. Trigger events that occur after DML operations are similar to the actions and related records option in record-triggered flows. After triggers are good for post-processing tasks like updating related records, sending notifications, or interacting with external services. For example, if we want to create tasks after an opportunity is created, we can use an after insert trigger to handle this requirement. A single Apex trigger can fire off of one or more trigger events. If an Apex trigger is built to handle more than one type of event, you'll need a way to decide which code should run for each event. This is where event checks come in handy. Let's say you have a record-triggered flow that is set to run whenever a record is created or updated. If you want something specific to happen when the record is created versus when the record is updated, you can use a decision element to handle this requirement. You will also have to decide what happens for each event in your Apex triggers. Event checks are conditional statements that control the business logic that should run during certain trigger events. For example, this Apex trigger is set to run before a product is inserted and after a product is deleted. This event check allows us to run a certain set of code before the product records are inserted. This other event check allows us to run a different set of code after the product records are deleted. With each event check, you will notice a few special variables. These are known as trigger context variables. In flows, you have the ability to reference new and old values or the records that triggered the flow. These values can be accessed through the record and record prior global variables. These global variables and flows are similar to context variables and Apex triggers. Trigger context variables allow you to access the records impacted by the trigger events and also allow you to know what's happening when a trigger is fired. This before trigger contains a few context variables. These context variables allow us to determine if the before insert event occurred, while this context variable gives us access to the product records that are being inserted. This context variable is being passed into a trigger handler, which is used to handle business logic. After the start conditions are defined for record-triggered flows, you are able to execute business logic. This business logic can be nested right within a record-triggered flow, or it can be accessed via a subflow. Apex triggers operate in a similar way. Technically, you can add business logic directly within an Apex trigger, but this goes against best practices. You can avoid adding any business logic directly in triggers by utilizing trigger handlers. Trigger handlers are Apex classes that contain business logic and can be called from Apex triggers. For example, this Apex trigger utilizes a trigger handler method that creates tasks for new opportunities. As you can see, trigger handlers provide what is known as a separation of concerns, which is a clean code concept. Trigger handlers make Apex triggers easier to understand and maintain. I just want to point out that all code is not perfect. So while using trigger handlers is best practice, you may encounter some code in the real world where business logic is nested within a trigger. Now that you have a high-level understanding of an Apex trigger, let me show you how you can add custom errors to your triggers. Record-triggered flows have a custom error element that allows you to stop flow execution and also display a custom error to users. If you want to throw custom errors in your Apex triggers, you can utilize the add error method. The add error method prevents records from being saved and also displays a custom error to users. For example, this Apex trigger utilizes the add error method to prevent users from deleting active products. Triggers in Salesforce are powerful, and great power comes with great responsibility. Triggers that are not optimized can lead to data and performance issues. So it is important to follow best practices to ensure that your triggers operate smoothly and effectively. You should also take some time to learn more of the advanced trigger concepts, such as bulkification, order of execution, and more. In order for you to truly trigger your coding powers, you need to start writing code. I can't stress this enough. Try converting your own record-triggered flows into Apex triggers. If you get stuck creating your own Apex triggers, don't worry. There are so many free resources available that can help you get a better understanding of Apex triggers. If you're looking for a fun challenge, I have a collaboration coming up that will give you some hands-on experience converting flows into Apex, so stay tuned for that. Regardless of how you choose to build your coding powers, your mission is to continue trying no matter how challenging it appears at first. Each challenge you overcome will help you improve and will get you one step closer to becoming a super Salesforce developer. Now let's go shock the world.